Okay, and let's just give you some. Let's just set the scene. Let's say we have two diseases. Okay, so let's just set the scene. We have two diseases. Okay, so maybe, or we have two different types of diagnoses that we're interested in. Or let's say we have two diseases. So we have two diseases. Okay, and the first disease is that you have chicken pox. Okay, so it's chicken pox, or another disease which probably which has been eradicated at this stage is smallpox. Okay, so we have two possible diseases. And what we know is this, is that when a patient comes to a doctor, so we have two things that we want to try to figure out. Okay? So that when a patient comes to a doctor, usually the patient is presenting with symptoms. Okay, so usually the patient presents with a set of symptoms, okay, and is looking for a diagnosis. And the symptoms with respect to both of these is that you're usually presenting with maybe a fever, and you're usually presenting with spots. Okay, so they're the symptoms. Yeah. Now, what we know is this, is that is that we know based off, let's say, of past evidence, yeah, okay, that a person that actually has chickenpox, okay, a person that has chickenpox usually has an 80% chance of actually developing spots, okay. Whereas now here's what's unusual, and this is the dilemma for a doctor. A person that has smallpox usually develops spots 90% of the time, okay. So the dilemma now that the doctor has is, okay, hang on, this person is in front of me, they have spots. So do I diagnose them as having chickenpox, or do I diagnose them as having smallpox? Okay, here's the dilemma. And the natural thing is, hang on, it's more than likely if they have spots that they're going to have, probably from a naive perspective as well, is that you can see that people that have smallpox get to have spots 90% of the time, whereas people that have chickenpox have spots only 80% of the time. Okay, so these are two probabilities. Okay, these two probabilities. This is the probability, okay, that you have, let's say, that you have spots, okay, knowing that you have chickenpox. Let's say the disease over here, which is chickenpox. Okay, in this case is 0.8. Whereas what this is saying over here is that this is the probability, okay, that you have spots, knowing that you have the disease, and the disease in this case being smallpox, okay, is equal to 0.9. Okay, let's keep that in mind. Okay. But what we also know is this, is that chickenpox, its frequency within the population. Okay, so its frequency, its natural frequency within the population. Okay. And this is based off past evidence as well, and data that's been captured, is that the natural frequency is usually around 10%. Okay, so about 10%. So it's saying that the likelihood that you have chickenpox is, let's say, around 10%. Okay, so the likelihood of someone having chickenpox, the disease, okay, is usually around 10%, whereas the frequency in the population of smallpox, and we'll just have something very small, the frequency of smallpox is usually 0.001. It's probably actually even smaller than that. Okay. So what the doctor now is interested in is, figuring out what's the actual probability that you have chickenpox, knowing that you have the symptoms. Okay. So in this case here, the doctor wants to figure out what's the probability, okay, that you have chickenpox, knowing that you have the symptoms. Okay, and over here the doctor would like to figure out is what's the probability that you have the disease, which is smallpox, knowing that you also have the symptoms, which is the spots. Okay, so we have to figure these two things out. Now Bayes' theorem tells us what we can do, and I'll just fold this page over so it actually fits up on top of this page here. Okay, so Bayes' theorem helps us out with this in this particular situation. Okay. So Bayes' theorem, as I said earlier, okay, Bayes' theorem, the probability of the hypothesis given the data is the same as the probability of the hypothesis times the probability of the data given the hypothesis divided by the probability of the data. Okay, so what we have here is that in this situation here, what we'd like to calculate is, we're going to calculate, so what's the probability of the data, okay, or what's the probability of the disease, okay, times the probability, okay, of having smallpox, knowing that you have the disease, so you're having the spots, knowing that you have the disease, divided by the probability of having spots. Okay. And over here, okay, this situation here is we have to calculate what's the probability of you having the disease smallpox times the probability, okay, D this time is ds, that you have spots, knowing that you have the disease smallpox, divided by the probability that you have spots. Okay. Now, there's one piece of missing information. You can see that we're given the prevalence of chickenpox